It sounds like we are live. Welcome everyone to the first live AP Computer Science A live lesson. This is 9.1, creating superclasses and subclasses. Hopefully everyone was able to get connected okay and is ready to go. My name is Rob Schultz. I teach AP Computer Science A as well as several other computer science classes at Bellbrook High School in Bellbrook, Ohio. And I'm going to turn things over to my partner, Jill Westerland.
Hey everybody, I'm Jill Westerland and I teach at Hoover High School in Hoover, Alabama. And we want to give you a little insight about us and where we are and help you place us. This is sort of a very abstract map. We couldn't get it all on here, but we got what we could. You see some pins dropped. My school colors are orange and black, so I'm toward the south, and Mr. Schultz's school is purple and gold, and
Go Eagles.
That's right, he's up north. And then we have a little yellow dot for our support system. So you might come to know more about our CL support. So here we are a little bit closer in. You can kind of orient yourself. We want you to come to see that you are our priority. We want you to place yourself near us, far from us, but with us right here online, all around the globe. We're honored to serve as your support system for AP Exam Review. We're so privileged to come alongside your teachers, whether you are a student in San Diego or New Orleans or Bergenfield, New Jersey or Austin, Texas. We are just happy to serve you in this way, and we're so happy to have the opportunity. So find yourself on the map and join us for the next, 5 weeks or so as we go through the Computer Science A course and get you prepared for the 2020 exam. So here's what we know about the test this year, the assessment this year. You're not going to have a multiple choice exam. You're going to be assessed on units 1 through 7, and I'm going to show you what that is in just a minute. So if you're thinking, oh my goodness, I don't know what 1 through 7 are, you will know by the time we get to May the 1st. You're not going to be assessed on 2D arrays, which is unit 8, inheritance unit 9, or recursion unit 10. It's going to be a different kind of test. It'll be 45 minutes long, and you're going to be taking it from home or wherever you happen to be on the test date. We will know more about the test on April the 3rd. And our goal, Mr. Schultz's goal and my goal, is to equip you for that test in terms of content, but also as we get closer to the test, we're going to equip you with specific strategies for this year's exam, how to take it, what do you need to have in front of you, what do you need to have in terms of technology. So we're going to be watching, everybody will, for April 3rd. So you might be wondering, well, if units 9 and 10 are not on the test, why are y'all starting with units 9 and 10? Well, we have some answers for that. So the first thing is that we're covering the content that colleges have asked the AP program to ensure that we cover. You might be a senior and headed next year to college, and you're going to be a CS major or an engineering major, and you may choose to go straight to the second course, which could be data structures. So it would be not a good idea for you to show up in data structures, not knowing what inheritance was and not knowing what recursion is. So we're going to start with those 2 units, which are the last 2 units of the course. And it just might be that your teacher was close to those units. Maybe they already covered it, or maybe you had not gotten there. So we're going to cover those in hopefully a very relevant way to you. We've developed some materials that we think you can customize and kind of dive into. So here's our schedule for the next 8 days. We're going to start with inheritance and then go forward into using a class to build an array, doing some things with that array, and then coming back to recursion so that you actually search and sort your array list. So now let's look at the big picture of the course that we all love as Computer Science A. You may not have ever seen this image. Your teacher hopefully has. This is from the course and exam description. And I know it might be grainy and it might be small if you're watching us on a phone, but just let me kind of unpack it a little bit. so that you can see where we fit during these weeks in relation to the whole course. So we are going to start with Unit 9, Inheritance, and we're going to be talking about how classes interact and really scratch the surface of what object-oriented programming can do so that you have a working knowledge of class interaction and how to move data up and down the hierarchy. Then we're going to go a little bit to the left and jog over and pick up the concept of array list, because we're going to build an array list off of a class of your choosing. And then we're going to use that array list to apply some recursion and write a method to recursively search your list. After that, we'll be at, I don't know what the date would be. It'll be the Monday after next Monday. We're going to go all the way back. So pretend like we're in a loop. And we're going to go all the way back to Unit 5, and we're going to actually slowly and methodically break down writing classes and map that really in a linear fashion to free response questions. And we're going to do a little bit of that before, but a lot more deliberate and slower. Then we're going to have a week on arrays, one-dimensional arrays, methods with arrays, what to do with arrays. After that, we're going to come straight on forward and hit Unit 7 one more time and go a little bit slower with array lists. So I hope that you're seeing some words that you've gone through in your classroom this year, and you're feeling like you can connect to what I'm saying to you in terms of our schedule. So don't panic that we're starting in Unit 9 and 10. Just bear with us, and there's a method to our plan. While we're working on Units 5, 6, and 7, we're going to pick up concepts from Units 2, 3, and 4. So Units 2, we're going to be picking up strings, and we're going to spend a whole week on string methods, because if you've done some work with free response, you know that they love to include that and kind of wrap that in with a different kind of free response question. From Unit 3, we're going to be picking up if else and using selection. And then from Unit 4, we're going to go back to our always friend, the for loop. So we are so happy that you're with us, and I wanted to explain to you this approach that colleges have asked us to do and why we're doing this content. In about a week, we're going to release a calendar that'll show you everything we're doing all the way to May the 1st. So I hope that that helps you see our big picture. What we would love for you to do, either now if you have anything near you, or you can rewatch this video at another time, we would love for you to have a notebook or some paper and a pen or a pencil when you're, interacting with us in our exam sessions. There might be things you want to write down, and we definitely want you writing code. So our approach to what we're doing, every single session that we have is going to be course focused, those 10 units that have been laid out for us that are approved for this course and that will get you ready for college. And we're going to be concept based, and we're going to focus on syntax, because your assessment, remember, is going to be you writing free response questions with your own hand. So I know some of you don't want to write code by hand. Probably none of you do. I find that in my classroom at Hoover, Alabama. But you're going to have to write code by hand for your assessment. So I'm going to ask you to first write code by hand that we ask you to work on. And then second, test your code by putting it in an editor if you can. You may be watching us on your cell phone, and you may not have any way other than a cell phone to interact with this review session, and that is okay. Please do not panic. I've got resources for you. I don't want you to feel left out. We're going to do everything that we can to have you ready, but just remember that your assessment's by hand, so there's nothing wrong with you doing everything that we do by hand by writing code. So take a minute, grab a pencil, some paper. Maybe you have an old notebook that's partially used from a class that wasn't your favorite last year, and you can make that notebook your favorite and let it be your Java notebook for the spring. So Mr. Schultz is now going to present our lesson for today, and then I'm going to come back at the end and talk about what we have to power you up.
Okay, hey, thank you. Pardon me. So like I said, our goal for today is to start learning a little bit about inheritance and how we can work with classes to create a hierarchy of classes to benefit us in a lot of ways when it comes to object-oriented programming. So some prior knowledge that might be helpful. We're going to rely a little bit on knowledge of creating a class that comes from Unit 5 and the types of methods, constructors, mutators, setters, or accessors and getters. So, so we're going to draw a little bit on the knowledge that we've got from Unit 5, and then we're going to learn how to create a hierarchy of classes. And we're also going to learn when to create a hierarchy of classes, because sometimes it's appropriate to create a hierarchy. Sometimes it's not. Sometimes we can force classes into a hierarchy where they really don't fit. So that's our goal for today. So let's jump in. Here we go. So first, a warm up. I would like you to take 2 minutes and think about the things that Bo and JJ have in common. As you can tell, Mrs. Westerland and I are both dog people. We love our dogs. So we started trying to come up with a fun way to get some of the ideas across, and we're going to focus on Bo and JJ for part of this lesson. So I'd like you to think about the things they have in common. Now, I'm going to caution you a little bit that we could go down the rabbit hole here. We could spend an entire day looking at all of the things that they have in common. So we're talking just on the basic level. I know you're also thinking, okay, they're two totally different breeds of dogs. They do things differently. They walk differently. They run differently, and they bark differently. So we'll deal with that kind of stuff and how we're going to deal with the differences between two different objects when we get to overriding methods on Friday. Today, I just want to focus on the basic things they have in common. So take a couple minutes. You could even think of it in terms of objects. We have a Basset Hound object and we have a mixed breed object. And think about the properties and behavior of those types of objects. You know, I said we were going to refer back to Unit 5. Anytime we create a class, we have to think about the properties and the behavior of that class. So when we create our Basset Hound class and our mixed breed class, think about the properties and behavior that those two classes would have in common at a basic level. I'll give you about 2 minutes while I sit here and kind of stare awkwardly at the screen. And I'll kind of step back in and show you the list I came up with, and then we'll kind of work from there. Okay, so 2 minutes. Okay, we've got about 30 seconds to go. I feel like we need the Jeopardy theme song playing in the background or some kind of elevator music or something, just so that it's not dead silence during these little breaks. But so see if you can bring your list to a close. We've got about 15 seconds to go. And then I'll show you the list.
Channel in music theory.
Oh, we could
sing or hum for them, but we're not music theory.
I don't think I'd do well in that class.
No, I can't hum or sing for anybody.
Okay, there's our 2 minutes. Here's the list I came up with. And again, when I put this together, I wanted something just that I could use as an example, and I wanted just the basics of what a Basset Hound and a mixed breed might have in common. So again, we could come up with hundreds of properties and hundreds of behaviors that those two breeds of dogs, or I guess a mixed breed and a Basset Hound, would have in common. But I just wanted to come up with something simple. You know, every dog, regardless of its breed, has a name, has an age, and has a weight. That's common no matter what the breed is. For my list of behavior, I threw in a couple of getter methods just so that we have a means of getting the dog's name or getting the dog's age, getting the dog's weight. And then on a basic level, you know, pretty much every dog breathes the same way. You know, they inhale, exhale, inhale, exhale. They all sleep the same way. And I also added a two-string method. And you're going to notice that as I go through this, there'll probably be a couple places here and there where I kind of jump back to Unit 5 just for some quick review. Just a couple comments about a two-string method. And while we're talking about inheritance, every object we create, whether we extend another object and we build it into a hierarchy or not, it automatically inherits a basic two-string method. And if you've never discussed the two-string method in your class before, the purpose of two-string, at least the way I present it to my students, is that it's to return the state of the object. It's to tell us what the contents of the properties are at any given point in time. And we'll talk more about state of an object, and we'll get a little more into two-string tomorrow. There's going to be a sample that I'm going to pop up on the screen in a couple minutes, and I'll show you my two-string method. But tomorrow, when we talk about constructors in subclasses and superclasses, we'll talk a little bit more about two-string and the state of the object and things like that. So just for now, understand that the purpose of two-string is to tell us the information that's in our properties. It's to tell us the dog's name, age, and weight. And that's, again, going to be common for both dogs. Okay, so if you have things that aren't on my list, you are perfectly fine. If you matched my list, that's great too. But this is the list I came up with as far as things that both dogs would have in common. Okay, so now let's get to the good stuff. This is the stuff that we're here for today. Okay, I want you to think about, as programmers, what kind of problems this could present as we start putting code together and we start building a program. Let's say we're designing a program for the American Kennel Club or for our local veterinary office, where we're trying to come up with a program to keep track of information about different breeds of dogs, or simulate dogs in a specific environment for some kind of a game we're creating. What problems could this present? And I know you can't answer back, so I'm asking hypothetically, I guess. To me, the biggest question would be, what if I want both dogs to behave the same, but I need to change a method? What if I decide I want to change my sleep method, but I still want both dogs to behave exactly the same? Well, now I've got duplicate code. I have to change the sleep method in the Basset Hound class, and I also have to change the method in the mixed breed class. So now we can expand on this a little bit. What happens if I want to represent every breed of dog? I checked earlier today. I did actually look this up. There are over 340 breeds of dogs that are currently on record known right now. So imagine we're representing all 340 plus breeds of dogs. All I want to do is change one line in my sleep method. Well, now with this setup, I have to go out, if I want all breeds of dog to sleep the same way, I have to go to 340 plus individual classes and change that one line of code to make sure that they all continue to behave the same way. That opens up a lot of room for mistakes, for things to be forgotten, for individual types of bugs, okay? So this is where inheritance really, really comes in handy for us. Inheritance gives us the ability to create a master dog class that has all of the properties and behaviors of a dog that we want to be in common across all breeds. Okay, so when you look at the diagram I've got on the screen, we have a dog class, just a generic dog class that has our properties. It has all of our methods that we want to share to all of our dogs. And then at the point when I create my Basset Hound class, or I create my mixed breed class, all I have to do is just tell it that that class is an extension of the dog class. So I'm going to jump out to JGrasp real quick. I know some of you probably use different browsers, different IDEs. And if that's the case, that's fine. In my class, we use JGrasp. So I've got a working copy of this. Mrs. Westerland, I'm gonna count on you. I'm still getting used to the whole sharing screens thing. So if I share the wrong screen or I'm talking about something that doesn't show up, jump in and save me, okay?
Okay.
So I'm looking at the dog class. This is our superclass. It has the private instance variables. You know, I shouldn't say always. I tell my students that 99.9% of the time we want our instance variables to be private.
Scoot just a little bit closer to your microphone.
A little closer to the mic?
There you go.
All right, thank you. I tell my students that it's difficult to deal in absolutes. 99.9% of the time, we're going to want our instance variables to be private, and we're going to want our methods to be public. There's always that odd case where we might want an instance variable to be public, or we might have a helper method that we want to be private. But in this case, all of our instance variables are private. I've got my constructor. So by default, when I create a dog object, the name is going to be Bingo, the age is going to be 3, and the weight is going to be 20.5. I've got just one getter method just so that I've got one there so that we can test a little bit. I have our breathe method and our sleep method, which really don't do much other than just display something to show me that I actually called the method. And then here's our toString method. The toString method takes the name, the age, and the weight, places them all in a string, and then returns the string. So that gives us the state of the object. What I really want to get through, though, and what I really wanted to show you was the Basset Hound class and the mixed breed class. So notice that both of these classes are literally empty classes at this point. They're just an extension of the dog class. I don't have any code. I don't have any methods. When I come out to my test program and I create a Basset Hound, JW dog equals new Basset Hound, and I tell JW dog to sleep. Let's see. Oh, whoops, I think I had a couple extra things turned on in there from testing. Let me comment this out quick. I'll get to this in a minute. When I run our test program, I'll try this again. All we're going to get is a little bit of a lag here. There we go. All we're going to get is these Z's from our dog sleeping. So even though there's no code in the Basset Hound class, all of that code is automatically being inherited from the dog class. So everything's still running the way it should, even though our Basset Hound class is totally empty at this point. Okay. So I wanted to make sure to get that point across. I'm going to jump back and share back to the presentation again. Let's go here. Okay, so.
Okay, we're still seeing Jay. There we go. We're good.
The main idea at this point is that the Basset Hound and the mixed breed classes become extensions of the dog class. And because they're extensions of the dog class, they gain all of the properties. And I wanted to specify this part. They gain the public behavior of a dog. So any method that's public automatically gets inherited by our Basset Hound and our mixed breed classes. If I were to put a method in there that was private, then the same rules apply as always with private methods. They're only available to other objects, only available to other objects within the dog class, okay? All right, so moving on. So with just two classes, with our Basset Hound and our mixed breed, you can see that that would already be pretty helpful. But once I kind of open it up and now I've got 340 plus individual breed of dog classes that all extend to dog, it makes it nice that all I have to do if I want to change my sleep method is go to the dog class, change the one line, and then it automatically trickles down the hierarchy to all of the other classes that are extensions of the dog class. So that's the first big piece of, the big piece of information regarding the power of inheritance in object-oriented programming, okay? All right, so next question. How do we actually create a hierarchy? If I have two specific objects, how do I know when one would be a good subclass of another and when one of the objects wouldn't? You'll hear programmers and you'll see textbooks and different educational materials in programming and object-oriented programming talk about the ISA versus the HASA relationship. And I'll be honest with you, this is a tough point to get across. I just started this unit with my own class last Thursday. And the fact that we're doing everything virtually just within my own class, everybody's doing all this from home, makes it even tougher to get the point across. So we were talking about examples of ISA versus HASA. A couple of my students were a little confused, and one of my students, Kai, stepped in and kind of took over the conversation and said, well, can't you just kind of think of ISA, you could replace it with the words is an example of or is a type of, and HASA would be has ownership of or it contains. And he was absolutely right. So I went ahead and added those quotes to my slide. Anytime we can take two objects and we can say that one object is an example of another object, or one object is a type of another object, that makes those two objects candidates to fit into a hierarchy, because we always want a subclass to be a type of the class that it extends. For example, a Basset Hound is a type of dog. It's an example of a dog. A mixed breed is an example of a dog. It's a type of dog. So it lends itself well to be a subclass of a class. On the other hand, the has a relationship more is an ownership thing. So, my dog, JJ, has a collar. I wouldn't necessarily say that collar is a subclass of mixed breed because I don't want the collar to take on all of the properties and behavior of a mixed breed dog. The collar doesn't breed, the collar doesn't sleep, the collar doesn't have a name, it doesn't have an age, it doesn't have a weight. So when we have an object that is connected, but it's not an example of, it's more of an ownership thing, then maybe a collar would become more of a property of a dog. We could have a Boolean property collar, true or false. Does the dog have a collar? Yes or no, true or false. So I'm going to take a little pause here for a second. Okay, we're going to do another 2-minute pause. We're going to do a check for understanding. And I would like you to take 2 minutes and make a brief list of objects that have an is-a relationship. So in other words, we want a list of objects where one object is an example of another object. And then I want you to make a list of objects that have a has-a relationship. One object contains the other object. Don't make it a huge list. Just give me 2 or 3 examples. Like I said, we're going to pause for 2 minutes while you're kind of looking some things over. Let me get back to my screen that has my timer. Okay, so let's say 2 minutes from now, and then we'll regroup. And again, I'll show you the list that I came up with. Go ahead and go, see what you come up with. Okay, we've got about a minute to go. I am definitely going to come up with some music to play when we have these little breaks. Okay, about 15 more seconds. Go ahead and start bringing your list to a close. Okay, let's see how we did. And I should probably throw in there that if you're watching a recording of this, if you're not watching it live, feel free to pause and take as much time as you would like. There's no magic rule about the 2 minutes. Just trying to keep things moving along a little bit. So here's the list I came up with. And the first one's kind of a cheat because we've already talked about basset hounds and collars. But I came up with a list. A basset hound is a type of dog. We've already given that example. A dog would be the superclass, and then I could come up with a lot of different breeds of dog that would be types of dogs. I came up with the idea of a pine is a type of tree. So I could have a superclass that's a tree that has all of the properties and behavior of just a generic tree, but below that I could have a pine class, I could have an oak class, an elm class, a birch class. I could have a generic car class, and below that have different types of cars. And the example I like to use in class, I like to use the doctor class. So we could have a generic doctor class. Anybody that is a doctor can write prescriptions, diagnose illnesses, do certain things. But then when you get to the individual subclasses below a doctor, you could have a surgeon class, you could have a pediatrician class, you could have a cardiologist class, a neurologist class. I mean, the list goes on and on and on. So these would all be examples of where we could create a hierarchy. Any of those is a type of or is an example of its superclass, okay? Now, when we shift over to the right side of the screen, we start looking at has a relationships. And I already gave the example of a dog has ownership of a collar. I wouldn't necessarily want the collar to take on the behavior and properties of a dog. I can't necessarily say that a tree is a type of forest. That doesn't make sense. So it wouldn't be a good relationship to make a tree a subclass of the forest class. What might make more sense, though, is within my forest class as a property, to create an array or an array list of trees. So within my forest class, I might have an array that contains 200 trees. It doesn't really make sense to say that an engine is a type of car or an engine is an example of a car. A car contains an engine. So an engine might be a property within my car class. And along those same lines, a doctor has ownership of a stethoscope. You know, most doctors, I think every doctor has a stethoscope. So it wouldn't necessarily make sense for a stethoscope to extend the doctor class and inherit the behavior of a doctor. A stethoscope obviously can't write prescriptions, but a stethoscope could be a property within the doctor class. So you kind of want to think about that a little bit as you start thinking about the relationship between objects and whether or not it makes sense to really make one an extension of another, okay? So let's talk about some benefits. We've already talked about the two big ones. We can avoid duplicate code and we can define a common protocol for a group of classes. If I have a group of dog classes that they all share common behavior, I can create a generic dog class, make every one of my breeds of dog an extension of the dog class, and then I can avoid duplicate code and I can share that behavior to all the dogs. We haven't talked about the one really big one. And the one really big one is polymorphism. That's the idea that object-oriented program is in my mind kind of built around. I know in my own classes, I refer to that term polymorphism several times throughout the year, but I don't feel like my own students really get it, or I would expect them to get it until we hit this point in what we're teaching. So for those that have never heard the definition of the term before, the definition I use in my class is that polymorphism is when we treat objects that are different the same. And a basic example would be telling an object to roll. You know, if I roll my neck, you know, that's one example of roll. If I roll a bowling ball, it's going to do something totally different. So I have two totally different objects that I can give the same instruction to, and they're going to behave differently, okay? So what we are able to do now, because we can start classifying groups of objects under one subclass, is now we have the ability to create an array or an array list with multiple object types. And that's always been something that's kind of limited us with arrays and array lists up to this point. You know, in the past, we could create a basset hound array called my bassets, and the only thing I could put into that array is basset hounds. Or we could create a mixed breed array called my mixed, and the only thing we could put in the mixed breed array is mixed breed dogs. So we've been a little limited in that point. But now that we know that both basset hounds and mixed breeds and all of our other 340 plus breeds of dogs are an extension of the dog class, I can create an array of dogs. And anything that we talked about up here that would be an extension of the dog class is fair game to go into the dog array, because a Siberian Husky is a dog. A chocolate lab is a dog. A mixed breed is a dog. A basset hound is a dog. So any dog that is a dog that I've declared as an extension of the dog class can now go into our dog array. So I'm going to jump back out to JGrasp again for a second and give you a little demo, because there's one specific point I want to make as we look at this. Let me jump back in. This is the part that I had uncommented before. All of a sudden, my screen is not cooperating. There we go. So I'm going to go to the dog tester. And now's where I want to uncomment this part, because I'm going to create an array of dogs. And there's a specific point I wanted to make. Keep in mind, and this is a little bit of a review of arrays when we're dealing with arrays of objects, that at the point where I say dog, our dogs equals new dog 3, I haven't actually created an array of dogs yet. All I've done is I've created an array of reference variables that can point to dog objects. So if at this point I were to go in and type system.out.println our dogs bracket 0 toString, or our dogs bracket 0.sleep, I'm going to get a null pointer exception because every one of the elements of our dog array is basically an empty bucket that is not yet pointing at a dog object. So when we create arrays of objects, don't forget that we still have to actually assign an object to each element, okay? So I'm going to go down and to kind of show the point, instead of having our dog array filled with only basset hounds or mixed breeds, I'm going to put a basset hound in position 0, a mixed breed in position 1, and a basset hound in position 2. And then I'm going to go down and just run a quick little for loop that's going to display the toString method for all of the dogs. So I'm going to make a little more so we can see this better. Okay, so now when I run, it's going to show us, it always runs slower when you're watching it and waiting for it. There we go. So it's going to show us the name, age, and weight for all 3 of our dogs. Now, the other thing I realize you're probably saying, okay, well, why are they all the same? Well, again, we set up our default constructor in our superclass, in our dog class, so that name would automatically be set to bingo, age would be set to 3, and weight would be set to 20.5. Tomorrow's lesson is going to be all about creating constructors specific to the superclass and the subclass. So tomorrow's where we'll deal with that. Tomorrow's where we'll add a little flexibility that we can give our dogs different names as we create them. But I wanted to make sure that we were all comfortable with the idea that now we can put multiple breeds of dogs into the same dog array, because technically they're all dogs. They're all an extension of the dog class. Let me see if I can jump back to the presentation one last time. And there we go. Okay, so here's our debrief and summary. That's as far as I wanted to get today with inheritance. And again, we're gonna add a little more tomorrow, and we'll add a little more on Friday. The big ideas of inheritance. Inheritance allows us to easily manage groups of similar objects. I can avoid duplication of code, and I can define common behavior for a large group of objects. The other thing inheritance lets us do is it lets us take advantage of the concept of polymorphism. It lets us start treating multiple types of things in the same way, because now they share a common behavior. Even if they do things differently, which eventually we'll get to that point, we can still make sure that we tell all of our different breeds of dog to do a specific part of their behavior. We can implement a specific method because we know that every dog will be able to implement that. Okay, Mrs. Westerland, I'm going to pass things over to you.
All right, thank you. So I phoned a friend the other day if we were playing that old game. And those of you who know me know my teacher friend is Gina. And I said to her, what's a better way to call our homework? And we're going to call it a power up, because we were informed that in gaming, power ups is how you get added enhancement, you get more features or more capabilities. So that's really what we want you to have during these weeks is, so every day we're going to have you a power up lesson, hopefully something that you can work on specific to computer science A and getting you geared up toward your AP exam for 2020. So I've made a bit.ly folder, and you can see the URL link here, and they are case sensitive. So I've got this reminder, and I'll try to keep reminding you. It won't take too long, and type it in a couple of times and your browser's going to remember. I'm going to share my screen now and go to the Google Drive and show you what's there. So when you go to the share drive, this is what you're going to see. Actually, you're going to see one step out. I've got a folder for each day. So there's a folder for today. There are a few resources for today. And I've given you a power up, sort of like homework plan in PDF format. And I'm going to try to do it in a consistent way each day, really referencing you back to the course and exam description. And I hope that your teacher at your high school has continually throughout the year preach to you about the course and exam description. You're going to hear it a lot from Mr. Schultz and from me. I'm going to go and show it to you now. Please bookmark this, or ever how you save things on your side of the computer. This course and exam description, is College Board's book to you about the Computer Science A course. Everything you need to know about the learning objectives for the course, the skill sets that you're supposed to be developing, the exam components. There are some sample questions. You might have gone through those with your teacher. So we're going to be continually referencing back. I want you to also get comfortable with this book and spend some time, hopefully, looking at the content. Each unit in the book and each lesson has a linked resource from almost all of them do from Runestone, which many of you may be familiar with. This is definitely accessible on a cell phone. So if you have a smartphone, you can go through the APCSA course on the Runestone. You can read, you can practice. There's boxes to type in code. There's also this introduction to polymorphism document that it's a little more teacher facing, but I felt like it would still be useful to you. What I would love for y'all to work on tonight is I've given you a different pitch, a little spin-off of Bo and JJ, and we've gone up the chain a little bit to just an animal class. And I've given you a UML diagram of a 3-level structure. So hopefully you found a notebook, you've got some paper. I would love for y'all to sketch out a 3-level diagram for classes that can inherit from one another. An animal class would be the superclass. Wild or farm animals could be our subclasses, and you may want to change that and make them different. Totally fine. It's your case study work. And then the 3rd-level class, and you can read my instructions there. And then on the 2nd page, I talked to you about other hierarchy topics. I've given you a linked brainstorming list that I came up with the help of a student, and maybe an image. I like to write things down, and again, go back to my speech about writing code. Plan your code on paper, think through your code, and we're going to be encouraging you to write your code. So that's your power up for today, and a couple of pictures in the brainstorming guide. And you can see the other resources. I want to pop back to the main level. We are close on time, like 2 minutes to Wapner, right? So resources and README. I've given you a copy in PDF form of the course and exam description. So if you don't want to follow the link, you've got it there. Endorsed providers. So we've got some groups who've come forward in our community and provided course materials specific to Computer Science A. I've linked the ones there that are free. I've also linked Java editors that are free, and I've kind of indicated which ones are available on phones, and you can see the rest of the things. So take some time and look at your resources, and hopefully take some time tonight and do a little bit of powering up in Computer Science A. And we are so happy you joined us today. We hope that you come back tomorrow and walk through this exam review with us. Take care, everybody.
Thanks for watching, and we'll see you tomorrow.